Alright, so I'm going to be walking through how to generate an infographic in RStudio. And an infographic is essentially a display of multiple different graphs or graphics and plots that are related to one another. So displaying them together makes it a little easier to compare this information, compare and contrast this information. And it makes viewing this information a little easier for the reader. And these plots here are just based on a mock data set that I imported earlier. And to import that data set, I clicked Import Dataset here. And my data set was saved as a CSV file, so I clicked From CSV. Then I browsed for my data set. And my data set was saved to my desktop, so I just browsed here. And once I've located that data set, I selected it and hit Open. Once I do that, we see that R brings up a data preview to see if that's the data set that I want to use. And this is the data set that I want to use for this particular video, so I'm going to go ahead and import that data set by clicking Import. And once I do that, this data preview appears again in this second window here. That way, if I need to refer to the data set at any point in time, I can do so by just switching windows here. But okay, I'm going to flip back over to my R script file here for my infographic and talk a little about what some of these different commands mean in order to generate this particular type of infographic and how we displayed some of these plots, where we displayed them. Okay, so at line 1 here we have a par command, and a par command is essentially the command you use when you want to set or indicate that you want to set a different graphical parameters. And in this case, I wanted to indicate those parameters in a list using this no.readOnly equals true argument, and I wanted all this information to be coded into the variable def.par. And then I wanted to open and interact with my data set, and to do that I needed the package readXL, so I used the library command to open the package and be able to read and interact with my data set. Like we see here, where the data set I selected earlier that I imported, which is salaries 2, but I didn't like the name salaries 2, so for this example I just recoded the data set name using a push command here to test data set. But okay, so once you've done all that, now it's time to actually set the parameters of your infographic. And to do that, the first command I used here was a layout command, and a layout command allows you to specify that you want to plot different plots in a format, a particular format. So in this case, I wanted to plot multiple plots within the same window. And to do that, I indicated that I wanted to plot this information in this layout in a matrix. And I did so using a matrix command. And a matrix command just allows you to specify where in the layout you want to place the plots. And in order to do that, you have a C command here which lists a series of values, and these values correspond to the plots in the order in which they were run. So this first value here, this 1, corresponds to the bar plot that I ran. This 2 value corresponds with the histogram, and this 3 here corresponds to the density plot that I ran. And the position, so that's the number, but the position in which the numbers appear indicates where in the layout I want to display that particular plot. So this first value here indicates that I wanted to display the plot in the first quadrant. But I also wanted the plot to display, because I only have 3 graphs, so I wanted the plot to display in the rest of the third quadrant here, so that this particular bar plot takes up 2 spaces or 2 quadrants rather than just 1. And then we see that my second value here, my histogram, is plotted like so in the my second quadrant, and of course my third plot is plotted in my last quadrant here, in the fourth position, which is where the third plot appears in my list. But okay, so now that I've indicated where I want the plots to be placed in the matrix within this layout, I've now indicated using this value, comma, value series that we've got here, I indicated the number of columns and the number of rows that I wanted this matrix to have. And so if you were to count, it would be quadrant 1, quadrant 2, quadrant 3, and quadrant 4, which corresponds to this, again, to the position that these values appear in within this list. This by row equals true command tells R that I want, when the plots are generated, that they appear in the form of rows, or that you're making the flow of the, in other words, you're making the flow of the matrix appear in row format rather than, so it'd be, like I said, 1, 2, 3, 4, rather than 1, 2, 3, 4, if it were columns. So now that I've indicated where I want my plots to be placed, I now use another par command to set another graphical parameter, which is, in this case, the margin of these particular plots, so I can arrange them and size them in order to make them fit within this window in a nice, neat fashion that doesn't overlap and misconstrued information. And I did that using a mar equals command, which refers to the margin, of course. But this time, our list with a C command here indicates the particular side of the plot in which I want to adjust or scale. And so the position for that would be this first position here corresponds to the bottom, second position left, third position top, and the fourth position right. So if I were to adjust these values by, say, a couple decimal points or even whole numbers, it would change how my graphs were displayed based on these margins. So once I've set those parameters, I'm now ready to plot the plots that I want to, or indicate which plots I want to plot and have appear in my infographic. And the first plot we have is a bar plot. And to generate that, I indicated to R that I wanted to plot a bar plot using a bar plot command, and I wanted that bar plot to show in the form of a table, and I wanted that table to be based on the variable rank. And then, of course, I use a main command to indicate and specify the title of this particular plot, which is number of professors by rank in this case. And then I used a xlab command to indicate the x-axis label, and a ylab command here to indicate the y-axis label, which is number of professors, right? So now that I've indicated how I want this first plot to be plotted or generated within the layout, I moved to my second plot, which is a histogram, and I did that using, or indicated that using a histogram or hist command. And within this hist command, I've indicated that I wanted the histogram to be based on the dataset test data, and within this dataset, I wanted to select the variable salary, and I did that using a $sign command, which is a select indicator, essentially, within R. So we see that my histogram has appeared here, and then we have this breaks equals 50 command. And this breaks equals command essentially specifies the number of bars that you want to appear in your histogram. So I could change this number to 25, 100, and that number, that specified number of breaks would indicate the number of bars that were displayed in this histogram. And once I've indicated that, now I indicate the variables that I want to use. So this first variable was, or the second variable I want to use rather. So this first variable was salary, and the second variable I'm indicating that I want to use the test data set again, and that this time I want to select the number of professors, which in this case, because it's my second variable, it shows up as my y variable rather than my x variable here. And this time I don't need a breaks command because my histogram is being displayed vertically, so the breaks are only going to appear vertically rather than horizontally like this. And then I used an xlab command to indicate the label that I wanted to use for my x-axis, and I used a y command to indicate the label for my y-axis, which is number of professors, and then I used another main command to indicate the title of the histogram, in this case, professor salaries. And then I used another, at line 9 here, I used another par command to indicate the margin for this plot. And in this case, I wanted the plots to all be roughly about the same size or with the same scaling, so I used the same values in this list that I used for the first one. So that's how I generated the first two plots. With the second plot, the density plot, I needed to open a new package in order to work with the density commands here. And to do that, I used another library command to open the SM package, which again allows me to work with my density functions, my density commands. And then at line 12 here, I have a factor command, which essentially allows me to specify the characteristics of this plot that I want to indicate. So, for example, I specified that I told R that I wanted to use the test data set, or the data set test data, and within this data set I wanted to select rank, and then I wanted that information to be displayed based upon these different characteristics or these different parameters. In this case, I was indicating to R that with this levels command that there are four levels within this data set that I wanted to indicate. And if I were to pull this out here, we see that 4 lines in my density plot appear. 1, 2, 3, 4. And then, so once I indicated how many levels there were in the data set, I then used a labels command to indicate what I wanted each of these lines to refer to, or each of these levels. So in this case, I wanted the first level to refer to assistant professor, second level associate professor, third level professor, and fourth level full professor. And I wanted all this information to be encoded in the variable rank.x, and I indicated that with a push command. So in other words, what I've done here with line 12 is establish the number of lines that I want to display, and which, in my legend here, which lines refer to which values. Anyway, and then I've indicated that I wanted this information to be coded into this variable so that I don't have to retype all of this information into my next line of code here, which is my sm.density.compare command, which allows me to generate a density plot and then compare the different levels of my rank variable in this case. And to do that, I've indicated that I wanted to use this command with the sm.density.compare command. Then I've indicated that I wanted to use the dataset test data and select salary as my x variable again. And then I wanted to, then I again selected test data as the data set I want to use. And then my second variable in this case is rank. And then I have an xlab command which allows me to indicate my x variable label. So essentially what this means is I've told R that I want to graph the different ranks within the categories of professorship to be graphed in terms of their salary, the current salary that these professors in this data set are receiving. And then I want to compare them based on their density. So I'm able to do that with these different color-coded levels here. And then line 14, I needed to add a title. So I did so using a title command and a main command here to specify the script that I wanted to use for that title, which we see is salary by rank. And then I wanted to generate a legend here in order to indicate what these different lines are referring to. And to do that, I used, in this case, it's a cold fill variable that I wanted to code all of this information here in. So all of this information like so. I wanted to encode that information into this cold fill variable. And I did that using a C command where I indicated the number of levels, and then I indicated the number of values within this list, which in this case is still 4 for this length command here. And I indicated that I wanted this the length to be based on the number of levels that I indicated in line 12 here. In which case, I'm telling R that I want all this information here to be based on the variable that I indicated in line 12, which is rank.x. And so that is so basically what I'm saying, to kind of break that down, is I'm telling R that I have 4 levels and that I want these levels to be based on rank, which is the variable that I've indicated here, and that I want those levels to correspond to these different variable names, which is again based on this rank variable, rank.x variable. And then in line 16, I'm indicating that I want to insert a legend in my density plot using a legend command. And this locator command tells R where within this density plot I want to place my legend. So if I were to run this again, we'd see that the plot shows up, but instead of an arrow, we see a cursor here, which tells R where my cursor is on the screen. So I just decided to click, if I just wanted to click here, that's where my legend would show up. So that's what this command does. And then I told R that I wanted the levels that are displayed within the legend to be based upon all the information in the variable rank.x that I indicated in line 12. And then I wanted to color code this information, otherwise it wouldn't be a very good or useful legend. So, and to color code that information, I used a fill command, and I filled the color based upon the information that I coded into this cold fill variable from line 15. And so that's how I generated each of these plots and how I placed them within this infographic layout. But now we have at line 18, we have a dev.print command, which tells R that I want to take this information in the window and I want to send it or have it generated in a PDF format. and I indicated how I wanted that information generated with a PDF command here, and then I just indicated with this text here, just indicated where I wanted that information to be saved and the file name that I wanted to indicate with this information. And then at line 19, we have another par command, and then we have our variable again, def.par. So basically what I've done here is indicated that I want to generate a set of graphical parameters in the form of lists, and I've indicated them in the rest of my code here, and I've coded this information into this def.par variable, and then at the end here, as a kind of closing bit of code, I indicated that I wanted all the information that I want to display in this graph or this infographic to appear based upon my def.par variable. And that's how you generate an infographic in RStudio. But when it comes to merging files, so for example, here if I go to let's go to an example PDF that I generated earlier. We see that I have a data file that includes a little introductory summary of the information and the infographic that I generated in RStudio. And to get this infographic and this introductory bit of information together in one page, I first generated each file separately. So you'll see here I have the infographic bomb bit of information here. That was the first page, and then I have the infographic information, and I saved the first bit, this introductory piece, as an PDF file, like so, and then I resaved the infographic output that I indicated earlier to my desktop. I resaved that information and saved it here under my assignment 3 file. And then I went to a website that was called pdfmerger.com. And then I just chose my files. So the first one I wanted to show up was this one, so I chose it. Okay. Then I chose my second file that I wanted to merge, which is my infographic bomb with my my plots on it, and I chose that one. And then I just clicked merge file, and what comes up is a merged PDF of your introductory report information and your infographic. Cheers.